guys, in this video we are going to discuss how to find LCM and HCF by prime factorization method. Fine. So we have found out the HCF using what is division, Euclid's division algorithm. So we are going to do find LCM and HCF by prime factorization method. Fine. We'll start. Let's get started. So basically you have to remember two things. That is, one is the HCF and the LCM. Two statements you have to remember. That is, for the HCF that you have to remember is that product of two smallest power of each common prime factor is in the numbers. So HCF is basically product of a smallest number power of each common prime factors. LCM, what about LCM? LCM will be product of So LCM will be product of the greatest power of each prime factor involved in the numbers. For understanding that, I have taken here two questions. So we'll proceed, or we'll find out the HCF and the LCM of these both questions. Fine. So earlier classes you have already studied that using prime, like using this thing, we can say 6 and 20. So basically you have done is that using prime numbers you have found out the prime factorization method, HCF. Then what about LCM? The same procedure, 6 and 20. Fine. 2 3s are 2, then 2 10s are 3 1s are, then 2 1s are 5s are 5 1s are 1s are. So basically, and you have to multiply this thing to get the LCM of 6 and 20. Fine. So in this method you are going to find using the powers. Fine, you are going to use the powers. That means first what you have to do is that first individually you have to take, like in the HCF, in the earlier classes you have studied that individually we have to take what numbers. Then using prime numbers you have to factorize this number. Suppose we will take 6 and 20. These are the numbers, right? So 2 3s are we can write, and 3 1s are. You have to use only the prime numbers because this is what prime factorization. Fine. Now what you have to do, then 20, what about 20? We can write 2 10s are, then 2 5s are, then 5 1s are, right? We can write it as this thing. So basically we can write 6 as 2 into 3. So 2 power 1 into 3 power 1. Fine. 2 into 3. 2 means we can write it as 2 power 1 also. Fine. Now what about 20? 20 will be 2 into, how much? 2 into 2 into 5, right? So we can write it as 2 into 2 into 5. So basically we can write 2 power 1 and 2 power 1 is same. So we can write it as 2 power 2, right? I hope this thing we know. 2 power 1 into 2 power 1, that is nothing but 2 power, adding the powers, that is 1 plus 1 is nothing but 2. So 2 power 2. Fine. So this thing we got. This is 5 power 1. Now, so basically to find the HCF, what you have to do, product of the smallest power of each common prime factors in the numbers. Now basically you have to find the product of the smallest power. Now 6 is nothing but 2 power 1 into 3 power 1. Here also 2 power 2 into 5 power 1, or we can say 2 power 1 into 2 power 1 into 5 power 1. So basically what is the common here? Common is nothing but 2 power 1 and 2 power 1. Fine. 2 power 1 and 2 power 1. No other things is common. 3 is not common. So we can say 2 power 1 and 2 power 1 are common. So basically what you have to do is that product of the smallest power of each common factors in the numbers. So basically we can write it as HCF as 2 power 1. Just you have to see the smallest power. That means we can see there are 2. Here 2 power 1 is there, 2 power 1 is there. These are the smallest powers here. Here also 2 power 1. So 2 power 1 and 2 power 1 are common. So we can write it as what? 2 power 1 is the HCF. What about the LCM? So LCM you have to see the greatest power of each common factors. What do you mean by the greatest power? Now basically you have to understand that greatest power of each prime factors. Here you have to understand that in HCF it is common prime factors, here it is each prime factor. So you have to take the each prime factors, that means greatest power of each prime factors. Here you can see 2 power 1 and here it is 2 power 2. So greatest will be which one? 2 power 2. So you have to take 2 power 2 Then product you have to do with 3 power 1 is also a prime number. So you have to take greatest power. No other number is there. Fine. 3 power 2 is not there, so you have to take 3 power 1 only. And what about here? 5 power 1 is there. We cannot take 2 power 1. Why? Because you have to take the greatest power of each prime factor. Greatest power, you can observe here 2 power 2 has the greatest power, so you have to take 2 power 2. So basically in the HCF and the LCM you have to understand that the difference is that here you have to take the each common prime factors, but here you have to take the each prime factor. You have to take each and every which has the greatest power. Fine. Now we are going to the next question so that you can clearly understand. Going to the next question. So fine. 12, 15 and 21. Again you have to do the same thing. 12 you need to find out, 15 you need to find out, and 21 we need to find out. Fine. So 12 we can say 2 6 are, 2 3 are, 3 1s are. Here 3 5s are, then 5 1s are. Here 3 7s are, 7 1s are. Fine. So basically we got all the prime factorization. We have done the prime factorization of each numbers individually. Fine. So first we will take 12. 12 is nothing but 2 into 2 into, so 2 power 1 into 2 power 1 into 3 power 1. What about 15? 3 power 1 into 5 power 1. Fine. Now what about 21? 21 is nothing but 3 power 1 into 7 power 1. So fine. So basically what you have to do is that now for finding the HCF you have to see the smallest powers of each common prime factors. So when you see what is common over here, so basically you can observe that 2 power 1 is not common, 3 power 1 is there in 12 also, 15 also, 21 also. So basically you can any other number, no, right? So we can write HCF is nothing but what 3 power 1. Fine. Okay. Now what about the LCM? For calculate the LCM you have to take what? You have to see the greatest power of each prime factor. You have to take the each power factor. Now you can observe that 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number. So you can say that 2 is a prime number, 3 is a prime number, 5 is a prime number, and 7 is a prime number. You have to take the greatest power factor. Greatest power you have to take. So basically you can understand here, this is 2 power 1 into 2 power 1. So you can take it as 2 power 2. Fine. We can write it as 2 power 2 into 3 power 1. Right. So greatest you have to take. That means 2 power 2 you have to take. So basically this becomes what? 2 power 2. 3 power 1 greatest power, which has the greatest power, this one only, right? 3 power 1, right? 3 power 1, 3 power 1. So greatest power of 3 will be 1 only. So 3 power 1. Now 5, again 5 power 1. 7 also 7 power 1. So we have to find or multiply these numbers. You will get 420 as the LCM of these three numbers. So finding the LCM is a bit, you can say, you have to understand and do. Suppose if you take here this question, previous one, see in the 6 and 20, between 6 and 20, so you have to see how many prime numbers are there. 2 is a prime number, 3 is a prime number, and 5 is a prime number. So 2, 3, 5 you take, multiply first. Fine. 2 into 3 into 5 you do. Now what you have to do, see the powers. Here you can see 2 power 1. Here it is 2 power 2. So you have to take the greatest power. That is 2 power 2 you have to take. Fine. Here it is 2 power 2. Here it is 2 power 1. So greatest power you have to take for the LCM. So 2 power 2 you have to take here. What about the 3 power 3? Only one number is there, 3 power 1. So take it as it is, 3 power 1. 5 also one number is there, 5 power 1. So take it as 5 power 1 only. So in the HCF we have to just see the smallest power, common you have to see. Here 2 power 1 is common. Here 2 power 1 is common. So you have to take it 2 power 1. Right. Here which one is common? 3 power 1. Fine.